Section 7.1 is going to cover right triangle trigonometry and its applications. So there are 4 objectives for this section. First being to find the values of trigonometric functions of acute angles using right triangles. Then we're going to use the complementary angle theorem, solve right triangles, and solve applied problems. So what we're going to do in order to find the values of trigonometric functions of acute angles using right triangles, in order to do that, a triangle in which one angle is a right angle, 90 degrees, is called a right triangle. So recall that this triangle has a hypotenuse, and then the side opposite our desired angle and the one adjacent are the legs. And because the triangle is a right triangle, I think I've said that a couple times now. Because that triangle is a right triangle, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. This figure shows that for an angle that is less than, is between 0 and 90 degrees, for theta measured in degrees, 0 has to be less than theta or less than pi 2 radians for a theta measured in radians. So that theta is never going to be greater than 90 degrees. So by referring to the lengths of our triangle by the names hypotenuse, opposite, and adjacent, we can find our trigonometric functions. Like think back to high school SOHCAHTOA. So sine of theta is opposite over hypotenuse, which is going to be b over c. Cosine of theta is adjacent over hypotenuse, which is a over c. Tan of theta is opposite over adjacent, which is b over a. Cosecant of theta, the inverse of sine, right? Hypotenuse over an opposite. Secant of theta is hypotenuse over adjacent. And cotangent of theta is adjacent over opposite. Keep in mind that now that we're in our triangle, right, that each of these trigonometric function values will be positive, because when we measure distance, like the length of a side of a triangle, it's always going to be positive. So this is where we get SOHCAHTOA from, right? SOHCAHTOA means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So for example 1, we're going to find the value of a trigonometric function from a right triangle. So we want to find the exact 6 trigonometric functions of the angle theta in this picture. Now I'm given my adjacent angle and my hypotenuse, but I need to find the opposite. And for that, we're going to use the Pythagorean theorem. So I have a squared plus b squared equals c squared, where c is our hypotenuse. So I have 3 squared plus b squared equals 5 squared. 9 plus b squared is 25. B squared is 16, so b is 4. And this 3, 4, 5 triangle, that's one of like our nice right triangles that shows up all the time. So now we can find our 6 values. So sine of theta is going to be opposite over hypotenuse, which is 4/5. Cosine of theta is adjacent over hypotenuse, which is 3/5. Tangent of theta is opposite over adjacent, which is going to give us 4/3. Then cosecant of theta, which is the opposite of sine, sine inverse, right? Well, not sine inverse, but it's the opposite of sine, would be 5/4. Secant of theta gives us 5/3, and cotangent of theta would give us 3/4. So that's how you find the 6 trigonometric functions from a right angle. Example 2. We're going to go ahead and construct a rain gutter. So a rain gutter is to be constructed of aluminum sheets 15 inches wide. After marking up a length of 5 inches, the angles are bent up at an unknown angle, theta, and we're going to express the area of the opening as a function of theta. How might we get started about that? Well, what is this length A? Here's my theta, so that makes this theta, right? So there's theta, that makes this theta, right? So I need to figure out the area of each of these triangles. So I need to find my length A and B so I can express the area. So I have that cosine of theta is adjacent, that's my A, right, over my hypotenuse, which is 5. So I multiply both sides by 5, I get that 5 cosine theta is A. Then I look at how would I get B? Well, B is the opposite. So if I have sine of theta is B over my hypotenuse, which is 5, I get B sine of theta. Sorry, 5 sine of theta is B. So normally the area of a triangle, right, area of a triangle is 1/2 base times height, right? Well, we have A, that could be our base, B is our height, so that's going to be 1/2 5 cosine theta times 5 sine theta. That gives me 25 over 2 sine theta cosine theta. But I don't just have one triangle, I have two. So I have to multiply that by 2. And that gives me 25 sine theta cosine theta is the area of the triangles. And the area of the square is just going to be B times 5. Well, B is 5 sine theta times 5. So the area of my rectangle is 5 times 5 sine theta, which is 25 sine of theta. So my area of my gutter, depending on theta, would be 25 sine theta plus 25 sine theta cosine theta.